أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقهوا قولي رب يسر ولا تعسر وتمم بالخير. Assalamu alaikum wa rahmatullahi wa barakatuhu. So today our lecture of linear control system is 12. So in the previous lecture we have seen the transition matrix, how we can obtain it from the system matrix A. So in this lecture we will continue the state transition matrix, but today we will see the properties of state transition matrix. So we have a few properties for the state transition matrix. Suppose that we have given the state matrix the state transition matrix is actually phi of t, which is equal to e raised power at, which is actually Laplace inverse of Si minus A inverse. So in inverse Laplace transform of the resultant matrix. Now so first property that we have seen is that it can be expressed as infinite series. It can be that we actually have seen and used it in the previous lecture. It can be expressed as an infinite series as e raised power at, which is equal to I plus at plus a squared t squared by 2 factorial plus a cube t cube by 3 factorial plus ak tk by k factorial and so on, which can be written as in the summation form, which is k is equal to 0 to infinity a power k tk over k factorial. So this converges absolutely actually for all values of t. So this converges absolutely for all values of t. So this is the first property of state transition matrix. The second property of state transition matrix is that if we evaluate the state transition matrix at time t equals to 0, so that will be identity matrix. So that will be the identity matrix is the identity matrix. And similarly, third equation, if we find the first derivative and evaluate it at t is equal to 0, so we will obtain the system matrix. That also we have seen in the last lecture. And fourth property is the state transition matrix is non-singular. The state transition matrix is non-singular and its inverse exists for all t. So its inverse actually exists for all values of the t. So it means that phi of t, so the inverse of this matrix will be equal to a raised power at, and that is the inverse, or we can write it as e raised power minus at, and that can be actually written as phi of minus t. So that's quite simple to find the inverse of the state transition matrix. And then again the other property is that phi of t into the inverse of this transition matrix, that will be actually equal to e raised power at into e raised power minus at, and that will be the identity matrix. So let's solve few examples to understand these some of the properties. So let's solve this example first, and it says that we have given this system x dot is equal to -1, 0, 1, -2 times x into 1, 0, 1, 0 times r of t, and the output equation is 1, 1 times x. Now what it's demanding is that we need to draw the state diagram, and then we have to find the eigenvalues, state transition matrix. So let's do it step by step. So the first part is the state diagram. So to draw the state diagram, we need to write down its state equations. So that will be x1 dot will be minus x1, and x2 dot will be equal to x1 minus 2 x2, and the output equation will be x1 plus x2. So we will draw this state diagram. So first of all, we know that this is y of t output, and we have here r of t as the input. Now we have these two states for this system. So we must have two integrators. Okay. So this one will be simply x2 dot. So after integration, it will be x2. So it will be x1 dot, and output will be x1. Now we have to draw these intermediate terms. So for x1, from x1 actually to here, we have this equation x1 dot is this that will be -1, and that will be our x1 dot will be x1 minus x1, and obviously this is r of t with it. I think so I missed it here. So r of t. So now it's okay. So r of t plus r of t minus x1 will be x1 dot, and x2 dot is actually x1, and it's summed with 2, again 2 with negative sign here. So this is plus, so that is actually x2 dot, and if we integrated this one, and what is the y? Y is simply the sum of x1 and x2. So here we have x2, so we will take this here x1, so that will be our y of t. So this is our state diagram for this system. Now the next says that find the eigenvalues. So for eigenvalues, second part says the eigenvalues. So to find the eigenvalues, we need to solve this determinant. So that will be actually equal to s plus 1, 0, minus 1, and s plus 2 equals to 0. So the characteristic equation of this determinant will be s plus 1 into s plus 2, which is equal to, which implies that s is equal to -1, -2. So these are the two eigenvalues for this system. So again, we can find out the next, it says that the state transition matrix. So the third part says the state transition matrix. So state transition matrix can be found out simply phi of s, which is equal to si minus a whole inverse, which is the resolvent matrix, and that is s plus 1, 0, and minus 1, s plus 2, inverse. So that inverse will be simply 1 over s plus 1 into s plus 2, and that is actually will be s plus 2, and this is s plus 1, and it will be 0 plus 1. So solving this, multiplying this inside will be 1 over s plus 1, 0, 1 over s plus 1 into s plus 2, and that is 1 over s plus 2. So to solve this, we need to use the partial fraction to separate these terms. So after applying the partial fraction, so what we will get 1 over s plus 1, 0. This will be 1 over s plus 1 minus 1 over s plus 2, and this is 1 over s plus 2. Now we will take the inverse Laplace transform of this matrix. So inverse Laplace transform of phi of s will be phi of t. So that will be e raised to power a t. So that will be simply, if we take the inverse Laplace transform of this matrix, so that will be e raised to power minus t, 0, e raised to power minus t minus e raised to power minus 2t, and e raised to power minus 2t. Okay. So we have now this state transition matrix, and then it says that find the transfer function. Okay, so and then we need to find the transfer function. So transfer function obviously can be found out easily with the relation y of s, r of s, with that will be c times si minus a whole inverse times b. So that will be simply 1 over s plus 1 into s plus 2, that the C matrix is 1, 1, and then we have si minus a inverse, and that is s plus 2, 0, 1, s plus 1 multiplied by the matrix B, that is 1, 0. So after multiplication of these matrices, we will get s plus 3 over s plus 1 into s plus 2. Okay, so let's look at another example. So in this example we have a minus 1, 1, 0, minus 3. Okay, so in this example what we need to do is that we have studied some these properties of state transition matrix. So by using its properties, we will determine its state transition matrix. So determine state transition matrix using its properties. So let's solve it and see how we can find out using its properties. So first of all, what we will do is we need to find out its eigenvalues. So to find the eigenvalues, we need to find the solution of this determinant, and this is s plus 1 minus 1, 0, s plus 3, which is equal to 0. So characteristic equation will be simply s plus 1 into s plus 3, which is equal to 0. So the eigenvalues are s equal to minus 1 and s equal to minus 3. So we will write the generalized state transition matrix, in terms of a polynomial. We write state transition matrix, transition matrix will be actually a polynomial in terms of e raised power minus t and e raised power minus 3t. So based on these two values, it will be generalized form. So that will be the phi of t, which is equal to e raised power at. So that will be we just write the coefficients e raised power a1 e raised power minus t plus a2 e raised power minus 3t, and similarly here we write b1 e raised power minus t plus b2 e raised power minus 3t, and c1 e raised power minus t plus c2 e raised power minus 3t, and this is d1 e raised power minus t and plus d2 e raised power minus 3t. So now we will use the property of the state transition matrix. Property is phi of 0 is identity matrix. So what we will do is we will use this property phi of, we will find this phi of 0. So that will be equal to identity matrix, this one, and this one will be simply a1 plus a2, and this one will be b1 plus b2. This will be c1 plus c2 and d1 plus d2. So that will be equal to 1 0 0 1. And also using the property, and also another property we will use, that is the derivative of this matrix evaluated at 0, that will be equal to the matrix A. So we will take the derivative of this one, and we will put it equal to A. So that will be that we will obtain as minus A1, and evaluating at e raised to t is equal to 0, 3a2, and then it will be minus b1 minus 3b2 minus c1 minus 3c2, and that will be minus d1 minus 3d2, and that will be equal to minus 1 1 0 minus 3. So now using these two equations, okay, so we will find out these coefficients a1 a2 b1 b2 c1 c2 and d1 d2. So using these two equations, we can write it as a1 plus a2 is equal to 1, whereas corresponding a1 plus 3a2 is equal to 1. So which implies that from these two equations, a1 is equal to 1 and a2 is equal to 0. Similarly for b1 plus b2, which is equal to 0, and b1 plus 3b2 is equal to minus 1, which implies that b1 is equal to 1 by 2 and b2 is equal to minus 1 by 2. So similarly for c1 plus c2 is equal to 0, and c1 plus 3c2 is equal to 0. So which implies that c1 is equal to 0 and c2 is equal to 0. Similarly for the d1 plus d2, which is equal to 1, and d1 plus 3 d2 is equal to 3. So solving these two equations, we will get d1 equals to 0 and d2 equals to 1. So now putting this all these coefficients into this matrix, so we will get the state transition matrix. So e raised power at will be simply, which is phi of t, will be simply e raised power minus t, and 1 over 2 e raised power minus t minus 1 over 2 e raised power minus 3t, 0, and e raised power minus 3t. So here we have seen that sometimes by using these properties, it is quite easy to find this state transition matrix instead of finding all the inverses and everything. And so this is the another way to find the transition matrix, state transition matrix. So I hope you have understood these examples or these properties of the state transition matrix. Still, if you have any queries and if you don't understand anything, please feel free to ask in the comment section. May Allah bless you. Assalamu alaikum wa rahmatullahi wa barakatuh.